Hi, Dr. Oliveira, and welcome to the Real Truth About Weight Loss Summit. Thank you so much for being here.
Well, it's my pleasure, Jay. You can have me as many times as you want and for as long as you want. I love talking to you.
Oh, this is going to be great. So I'm excited to ask you about genetics. What role do our genes play in being overweight or obese?
Well, this is a great question. I'm a geneticist by training, and as much as I would like to say genes don't play a role, because when we talk about, for instance, chronic diseases, we know that, for instance, cancer may be 5-10% related to genetics. But when it comes to overweight and obesity, it's actually the role that genes play. It's enormous if you think about it. And how is it that we know? How is it that we find out how much is it genes or how much is environment in any given disease? And right now we are focusing on overweight and obesity. Usually comes from twin studies. So what we do is we look at twins, and it could be, preferably, it would be identical twins that were raised separately. And we have many of those in the world that we can find. And if you see that identical twins that were raised in different countries, they'll have weights that are very similar, then the likelihood, and eating different diets, so the likelihood that genetics plays a big role, it's something that we can estimate, right? So, and there are other studies that are done with animals, right? Model animals that also allow us to infer how much or what is the percentage of genes that are influencing a certain disease. And when it comes to overweight and obesity, we know it's a big range, but it can be between 47% up to 93%, depending on the gene. And on average, then, we believe is between 70 and 80%. So, which is enormous than you think. So if genes are regulating 70 to 80% on average of our risk, then we would only have control over 20 to 30%. But here's the interesting thing. When we talk about genes being increasing our risk to any given disease, we always think, how can I say that? Let me go back. So cancer, 10% genetics, 90% environment. So we know we have a lot of control over it, right? But obesity, 70% genes. But here's the thing, the amount of genes related to obesity is very high. So up until now, we know there's maybe 120 different genes or mutations that are associated with overweight or obesity. So 120 genes across all of our chromosomes, all our 23 pairs of chromosomes. So that's a lot of genes, right? And some of them are what we call monogenic genes, so it's monogenic obesity, and some of them are polygenic genes or obesity genes. So what it means is if it's a monogenic obesity gene, just the presence of this gene, not the gene, but the mutation in the gene, is enough for you to present the disease, okay? So we're all gonna have all the genes. It's whether or not we have a certain mutation or not, right? But the majority of obesity that we are dealing now, this obesity epidemic that we are dealing now, is related to what we call polygenic obesity. It's a sum of the effect of multiple genes that will cause the phenotype being overweight or obesity, right? So I'm going to give you examples. And sometimes there are genes that can do both. It can be monogenic obesity or related to polygenic obesity. So an example of a monogenic obesity gene would be the leptin receptor gene. So we all have the gene and its function and it's great. But if we have a specific mutation in this receptor, then the brain doesn't see leptin. So we're producing leptin, but we don't have the receptor. It's not receiving the message. And then we're going to have obesity as a phenotype. What happens with monogenic obesity genes usually is that the person is going to have obesity very early in life. Why? Because it's very genetically driven. So there's no way around. So obesity, overweight and obesity that we see, which is afflicting most of Americans and most people around the world, like almost 2 billion people in the world are considered to be overweight. So that's polygenic. So it's like an array of genes all acting together. And one of the ones that is a major contributor gene for polygenic obesity is called FTO, or fat mass and obesity genes. And there's a third gene, and we're going to be talking about FTO a little more, so I hope, right, over the next 45 minutes, an hour or so. And there's a third type of gene that it can be either monogenic or related to monogenic or polygenic obesity. That would be, for instance, MC4R, which is melanocortin 4 receptor. So it's another receptor gene. It can be acting in one or the other. So then obesity, and when I talk about genetics, I always like to think about what is the evolutionary reason for these genes to exist, right? So is it just to punish us? Why is it that obesity is such a big deal, right? Why do we have over 100 genes that have already been identified, or mutations that have already been identified as increasing risk of obesity? So what are the roles that we play? What is it that we need to do as a species in order to guarantee that human beings are going to be existing on the planet for a long time, right? We need to do two things. We need to survive and we need to reproduce. So we never think about it. So are these genes helping us survive and reproduce? Yes, they are. Why? Because fat is the way we store nutrients, right? That's the way we store energy. So being efficient in storing fat allows us to survive, correct? And allows us also to reproduce, because we need fat in order to have maturation of our sexual organs. We need fat to produce our sexual hormones. So we need fat for both. So as you can imagine, we came with an array of genes that allow us to do both, survive and reproduce. So evolutionary speaking, or biologically speaking, it makes a lot of sense. Okay? The reality is, what we see in our bodies, what we call the phenotype, having the phenotype of being overweight or being obese, then it's an interplay of the genes and the environment. So if we have a very strong genetic component, and on top of that, we don't pay attention to the 20%, 30% that we have control, mostly the food we eat, then that's what we get. That's overweight and obesity.
Wow. But isn't weight gain or weight loss just a result of energy balance? Because a lot of people believe that it's just calories in, calories out. Can you comment on that?
Yes, absolutely. So if calories in and calories out was really the way to go, anybody following a calorie counting diet would succeed. And calorie counting would succeed forever, because it was simple math. If you know that you need 1,200 calories to survive, or 1,500 calories to survive, as long as you consuming less than that, you never gain weight. And we know that that's not the case. And one of the things is, people don't realize, they don't know, of course, you have to be a scientist probably to know this, but the center where we control energy balance is in the brain. So the three genes I just mentioned before to you, the leptin receptor, the melanocortin 4 receptor, MC4R, LPR, the other gene, and FTO, the fat, mass, and obesity gene, all three are highly expressed in the brain, because that's where energy balance is regulated. And all three genes are going to be expressed, right? Either you're going to be turned on or off. Not really on and off, because it's very rare that we turn a gene completely off or on based on environment. It can happen, but usually what we do is we make the light brighter, or we dim the light. So we're either going to go above what a threshold it was going to be considered normal, so to speak, or optimal, or we go below that level. So, and we think about those three genes, they're all regulated on the brain, and they are either made brighter or they're dim based on the foods we eat. So there are other things that are going to be affecting how these genes are expressed, right? Either turn up or down, and like exercise, the amount of sleep we have, and all of that. But food has a major effect. And not all the foods are created equal. You would think, as long as I eat 1,200 calories, it doesn't matter where the calories are coming from, because the effect I'm going to have in one gene or the other is going to be the same. But we know that's not true. There are two types of macronutrients. They're going to be having an effect on these genes different than any other type of micronutrients. And those are fats and protein.
So different genes have different effects in energy balance?
Yes, different foods have different effects on those genes. They're on our hypothalamus. So for example, and it's not just any fat, and it's not just any protein. It's specifically saturated fatty acids, and it's specifically branched chain amino acids. So, and what is the type of food that is naturally very high in saturated fats and very high in branched chain amino acids?
I'm going to guess animal protein.
Exactly. Animal foods, they're very high in both. And if we're just going back to one of the genes we just discussed, FTO, right? FTO has a specific preference for fats, and specifically saturated fats. So the more saturated fats we have in a diet, the higher fat content and the higher saturated fat we have in a diet, the more you're going to have FTO being turned up instead of being at a level that is regulating whatever function it is supposed to do. So that's one. And the second type of macronutrient will be protein, but more specific, we know that protein is formed by a chain of amino acids. But when we compare animal foods to plant foods, we know that animal foods are going to be a lot higher in branched chain amino acids. That's why they are known to cause growth, right? More than plant proteins. But not only that, it's like the type of amino acids, this of all types, the branched chain amino acids, specifically leucine, is the one that's going to be driving mTOR the most. Because like mTOR, we discussed this in the past, right? mTOR is the main driver of growth when we're talking about a baby, for instance, but it's also the main driver of aging past reproduction age. So, and what is it that controls mTOR the most outside of drugs? It's energy level, so how many calories we are eating, and the type of amino acids. And fat is what is going to increase energy the most, right? Because it's 9 calories per gram. And we also have amino acids, specifically branched chain amino acids. So those two. So it's not created. So if you're eating 1,200 calories, and in this 1,200 calories, you have high amounts of fat, specifically saturated fats, and you have high amount of certain amino acids, the branched chain amino acids, then FTO is going to be going up way more than it should, and that's how you have regulation. If you eat 1,200 calories and those 1,200 calories are coming from foods that are higher in fat, higher in carbohydrates, or we call intact carbohydrates, carbohydrates that come with fiber, low in fat, and low in branched chain amino acids, then of course it's not going to be calorie in, calorie out. This type of food is going to help you maintain your weight or lose weight versus animal foods, which are going to be exacerbating or up the expression of FTO, among other genes in our brain.
And how are some people losing weight on these high fat, high protein diets?
Great question. Well, one of the reasons is when you pass a certain threshold of fat, then you automatically are going to start eating less volume of food. And indirectly, you're going to start eating less calories of food, correct? So if you pass 60% fat, then the reverse happens, believe it or not. You start losing weight when you pass 60%. I'm not saying it's the healthy way to do it, but it happens too. But also, it depends on the amount of protein you're eating. High fat, high protein diets may cause weight loss at the beginning, but in the long run, your weight is going to start going up again. It's only when it's very high fat and lower protein is that you may be able to maintain, which would be the ketogenic diet. But it still wouldn't be recommended because you would have insulin resistance and you have all other types of effects in your health. That's not what you want, right? So you can lose weight any way possible, many different ways possible, good, bad, or neutral ways of losing weight. But there are some ways that are going to come with health and some ways they're going to make you more unhealthful, right? So a high fat diet will help you lose weight for sure. And you may be able to maintain, but that's not the way you want to do because the way your genes are going to be expressed in your brain is going to be all different than what you would expect to be the healthy way. I don't know if I'm making my point clear, but so that's the idea. It is possible. I always say it is possible to lose weight in a ketogenic diet, but it's not the healthy way. All your genes are going to be expressed differently, and it's not a way that you want to, for instance, I wanted to talk about microbiome with you, like maybe later, but a high fat diet is going to be changing the microbiota we have in our gut. A high fat diet is going to be changing expression, for instance, of BDNF gene, which is the protein. BDNF is a protein that clears our brain from beta amyloid, which is the main protein that we see a buildup in Alzheimer's disease. So we may see that we are losing weight, but at the same time, a high fat diet is changing expression of so many genes. They're going to have detrimental consequences down the road that you may not be seeing now.
Wow, that's so interesting. So what is the most genetically favorable, healthful way to lose weight?
Well, we know it's whole plant foods and a whole food plant-based diet that is also low in fat. It has to be low in fat also because of what we just discussed. And just to give an example, how foods were going to be having a direct effect on our genes. And I use the FTO because it's one of my favorite genes to talk about. FTO is a gene that in general is not expressed as much. Like it's what we call hypermethylated. So methylation is when we have a group methyl that attaches to a gene. It puts like a cap on a gene. And as long as you have that cap, the gene is not being expressed. And in the case of FTO, we want FTO to be really low expressed, right? So we want that cap in. Depending on what we eat, when we eat a high fat diet, or when we eat dairy specifically, this cap is removed, right? So we go to hypomethylation, when we don't have that, and then it can be red. So FTO starts being expressed more. So when we eat dairy, the cap is removed, and then FTO is turned up. But when we eat beans and greens, for instance, they're high what? In folate. Folate and B12 are two foods that are known, or two vitamins, so to speak, that do the opposite. They put the cap back on. So in one side, you can see eating dairy will make FTO be more expressed, and eating your beans and your greens will bring the cap back on. Just to give another example, it's not related to weight loss per se, but we know from prospective studies that women that eat the most soy foods are protected against breast cancer. You know, there are an old myth that is the opposite: the more soy foods, the higher risk for breast cancer, but we know it's exactly the opposite. And research has shown that soy also has an effect on whether or not the BRCA gene, which is the main gene that increases the risk for breast cancer, whether it is methylated or not. And the BRCA gene is the opposite. So all of this I'm talking is what we call epigenetics, right? So it doesn't matter whether or not you have a mutation in a gene, you can still prevent that gene from being expressed, or we can release it to be expressed, right? So BRCA gene is a gene that we want to be expressed. It's different than FTO. We want it. Why? Because it's a gene that suppresses other cancer genes. And if it's on, it's making the other ones go down. Okay? So, and then soy does exactly that. Soy removes the cap and allows BRCA gene to be expressed. Is that clear?
Wow, almost. I'm probably going to have to listen to this again. You make it sound so simple. You have an interesting story because you are an identical twin. So you and your sister share the same genes, yet at one point she was 50 pounds heavier than you. So,
yes.
and she also struggled to lose that weight. How is that possible? You guys are genetically the same.
Yes, we are genetically the same. And it's interesting if you think about it, right? So we had exact the same diet up until we were 22, 23. And at that time, it's when I decided to go spend a semester abroad. I went to Germany, and my sister stayed in Brazil. But it's not just that she stayed in Brazil. She also graduated from law school and started eating 3 meals outside the house every single day. So her diets changed a lot. And we like to think it's just excess calories that she was eating. But if we think, she loves dessert the same way I used to love dessert, right? We both love dessert. And if you're eating out every single day, the likelihood you're going to be eating dessert, it's very, very high. And desserts from restaurants are not easy peasy, right? So they're very, very high in dairy specifically. We were both vegetarians, by the way. So she wasn't eating the meat. It was mostly dairy. And I tried to think of any dessert, like the desserts we eat the most, they are not made with at least a little bit of dairy. It's like, I don't know. And basically all of the desserts we liked, all of them had massive amounts of dairy. And she loved chocolate too. And of all the foods out there, of all desserts, chocolate is one of the most fattening. We don't like to admit, we like to think chocolate is healthy food. Chocolate may be a treat if that's your thing, but chocolate is very, very fattening because of the amount of saturated fat. Remember when we start talking, I said high fat, specifically high saturated fat, will change the expression of FTO. So in this case, the saturated fat may not be coming from animal foods, from plant foods, but it's still something that is harmful, right? And if you're trying to lose weight, nuts are also very high in saturated fats. We don't like to admit it, but it's true. So if you don't look at how many nuts we are eating a day, it will also have an impact on our weight. So those are the two differences, I think, that happen with my sister and me. And then something that it's it's hard for people that were never overweight to grasp is that once you start the trajectory, even if you start changing, nobody start gaining weight and just don't do anything. Everybody starts gaining weight, gains 10 pounds, and then say, I need to do something about it. And they start a new diet. And then either they count calories or whatever it is, they're not just doing the best possible diet that we know what it is. So, but they try and they may find a way to maintain this 10 pounds, but they cannot go down. And then after a while, if they get tired of the one diet they try, because being on a diet is something that nobody wants to be, right? On a diet for the rest of your life. Then another 10 pounds come in, and then your weight stabilizes now at 20 pounds overweight. Then you try something else, you may lose 10 pounds, feel great, and continue the diet for a while, and then the weight's gonna come back. So the whole time, most diets are gonna be related to decreasing the amount of energy of what you eat, right? A whole food plant-based diet, if you think about it, is just like any other diet. You also change the energy density of the food, but you're changing the energy, but not the amount. And that's key because nobody wants to eat less calorie, but also less food. And the whole food plant-based diet allows you to decrease the energy without decreasing the amount. And that's why it's successful.
Right.
So,
and actually, sometimes you can actually increase the amount.
Exactly. So, and that's basically what happened to my sister over the period of like 15, 20 years. Her weight stabilized like 50 pounds above mine. And it was very hard to bring down. She was only able to bring it down when she started following a whole food plant-based diet, because now, like you said, she was eating sometimes even more food in volume, but the energy density of that food is a lot naturally a lot lower, and that's the way to go. Another thing that I like to say, and you probably, maybe you're going to ask me about it, is that if you've been overweight for a while, and like my sister case, it's been like almost 2 decades, once you lose the weight, the amount of food that you eat is not going to be the same as someone that has always been their weight. Like, for instance, my sister and I may be very close in our weight now, but I can eat way more food than she does, and I lose weight. And she eats less than me just to keep the weight. And I don't believe this is a life sentence, but it takes a few years for the body to adjust so that you can eat a little more without what we call a calorie penalty.
Wow. How much more can you eat than your sister at roughly the same weight, because you personally were never overweight?
Well, I never measure myself, but results from research done in Australia, also in the UK, and even in the US, they show that on average, someone that loses about 10% of their body weight, which is not a lot, right? So if you weigh 140 pounds, would be losing 14 pounds, which is if you're 50 pounds overweight, it's way more than that, right? So when you lose 10% of your body weight in weight, usually you have to consume an average of 25% less calories to maintain your weight. 25% is like 1/4 of the calories that somebody else can eat. Like, this is an enormous amount, right? Not to mention that fat cells, they only grow. We never get rid of them. So when you gain weight, you accumulate more fat cells. And when you lose weight, these fat cells, they just shrink. A fat cell can grow 1,000-fold its original size. So like, if we go back to the beginning of our conversation, remember, there's an evolutionary reason for it, right? A biological reason for it. It is what allows us to store energy for whenever we want. Can you imagine if we didn't have glycogen, which is like glucose stored, right? Or fat, we would not be able to stop eating because we need constant amount of glucose, constant amount of energy for our brain to work, for us to breathe, for us to walk, for us to do everything. So we need to be able to store. But if we're going to store the same amount of energy that we store in fat, we would need twice as much volume wise, right? So we can store 40,000 calories in 10 pounds of fat. If we were to store the same amount of glucose as in glycogen, we would need 20 pounds more. So it's a very effective way of storing energy. So it makes sense that we are so good at it. But the thing is, once you've been overweight, you accumulated, fat cells, they grow in number, but once you lose weight, they don't decrease in number, they only shrink. And as long as those fats are around, if you go off the wagon, then there's a penalty for you, more so than someone that never allowed the fat cells to grow in number.
That's not very encouraging, actually, because what you've explained, that is losing 10% of your body weight means you require 25% fewer calories. That would explain why weight loss maintenance is even harder than weight loss.
Exactly. It's maintenance is all hard, because my sister or many other people I've known, even my mom, many of the women in my family have had problems with being overweight. Some have had problems with being obese, and they never had trouble losing weight. They try 5, 10, 15 different diets over their lifetime. The problem is exactly what you're saying. It's maintaining weight. And even in a whole food plant-based diet, and you can speak more about it than most people I know, it's some people that women specifically, they can transition to a whole food plant-based diet. They may experience some weight loss. I experienced some weight loss myself, but because I was never overweight, I can get away with eating nuts. I can get away with eating soy foods. Like if my sister eats tofu, or edamame, she doesn't gain weight, but her weight loss stops. It's like it's the one food that will not allow her to continue to lose weight, because soybean is 30% fat compared to black beans, which is like 1% fat. So there's a difference. It's both beans, but they are not created equal. So that makes a difference. And people need to adjust. They need to know that's what is going on. And you, more than anybody, can speak to it, right? So you have been whole food plant-based for a long, long time, but only when you eliminated the higher energy dense foods were you able to actually get the weight that you wanted.
Absolutely. And I'm finding more and more people, especially women, have that experience. Do you think it matters, Dr. Oliveira, at what age we first attempt to lose weight, or how many times we've attempted to lose weight? So many people yo-yo diet. Does this make a difference in our ability to lose weight?
Well, yes and no. First, there is an effect of age in weight loss or weight gain. So when women go postmenopausal, then our energy requirements are 65% of when we are in our 20s. So there's a very big decrease, right? So we need to survive with 35% less calories. So it's like, even though you have never been obese, just going through menopause will decrease your calorie requirements. That's one. And there's also genes that will have a big effect when you age. For instance, FTO again. I told you I was going to speak about FTO many times today. We know that, so there's something called gene penetrance that we call it, saying what is the effect of the gene on a specific phenotype, I would say, a specific characteristic that we are measuring. We know that FTO is about, if I'm not mistaken, it's about 37%, the gene penetrance when we are in our 20s But when we're in our 40s, it's 60%. So FTO, the effect of FTO is a lot bigger the older we get. Okay. And there's also differences in sex, since we're talking about women, right? So the other gene I talked about, MC4R, we know that it's the effect of the mutation of or risk, right? Increased risk of obesity or overweight of MC4R is twice as big in women than it is in men. So there's all of this difference that we have to take into consideration. So women will produce less thyroid hormones as they age as well, and they will produce a lot less estrogen. And the one source, so the main source of estrogen after menopause is going to be fat. So if it is fat, biologically speaking, again, the body is going to do whatever it takes to do what? Make sure you keep your fat or you increase your fat, because that is your main source of estrogen after menopause. So it makes a big difference. And so after menopause, and if you have been overweight and now you lost weight and you were postmenopausal, then you have to really pay attention to what you eat. I believe it gets easier, but for at least 2-3 years until you reach your weight, you have to be very vigilant. And then once you're in maintenance phase, then it may give you a breather, but that's just the way it is.
It doesn't seem very fair.
I know.
You once sent me a really interesting article about salt and how that actually encourages the passive overconsumption of food, but particularly of fat. And that could be important in someone's weight loss journey. How does that work?
Yes. Fat, it's been a while since I read the article, but I believe fat increases our overconsumption of fat by 11%.
Salt increases.
Yes, which is a lot. 11% is a lot. And women, again, women specifically, are more responsive to this salt increase or salt related increase of overconsumption of fat than men are. So that's for sure. So salt will increase. The other thing, going back to FTO and MC4R, the two genes we talked many times during this our conversation, those two genes, if you have them mutated, if you have a specific mutation that increases your risk of obesity and overweight, they are the genes that increase your desire for high energy foods, for high fat foods. So can you imagine if you have the mutation, or if you're eating dairy and dairy is upping the expression in FTO, so it's increasing your desire to eat high fat foods. And if on top of that you add salt, then your desire goes through the roof. And there have been studies that show that the more fat we eat, the more the genes related to pleasure in our brain are going to go up, right? The dopamine receptors and the opioid receptors are going to go high, depending also on the amount of fat we eat. So that's why when we talk about being whole food plant-based, sometimes we don't express enough the necessity for their diet to also be low fat. Because being whole food plant-based is one thing, but if you're trying to lose weight or if you're trying to reverse a medical condition, you have to go very low in fat too.
Yeah, I agree. I mean, that's what I've been noticing with other people, myself included. All the experts are saying how just having extra fat on your body, it's not just an aesthetic thing. You're at higher risk for virtually all diseases. So many people have yo-yo dieted their whole life and lost weight, sometimes even 100 pounds many times. Are there any risks associated with this type of yo-yo dieting, or is any weight loss at any time still going to be beneficial?
Well, that's a great question. I don't know I have the answer for it. I'm thinking in my own experiment with my sister, what I've seen is that after she lost the first 20 pounds, so she still had more than half of the weight to lose, her markers were very identical to mine. So inside, the body was very resilient to bringing you to a position where you were before. I know two other things that we need to take into consideration. One is that it has been shown that once you've been overweight, that this region of the brain, the hypothalamus, where you control energy balance, that you can get some, it's like scar tissue. You have some scarring in this area that is there forever. It's like it's kind of a mark that you've been overweight, and it's there. The studies haven't been done in humans. They have been done in mice. When they overfed mice with saturated fat, saw the mice would be overweight, and then they changed the diet. And of course, in autopsies, they could see that the scarring tissue was there, it was present. So we think that is something that is going to be happening to humans too. So there's another reason why keeping saturated fat low after, first to lose weight, and second, once you lost the weight, is very critical. So, and the other thing I was going to say, what was it? I said this. The other thing is, if you go in yo-yo dieting, what I can think of is, as long as the extra number of fat cells are still in your body, the potential risk for disease is still there. You know what I mean? So if you think that adipose tissue will have the power to, for instance, produce more TNF alpha, to bring more macrophages, to stimulate low-grade inflammation, I would think that as long as you maintain the weight, the risk may be low, but you have to be very vigilant not to allow the weight to come back again, because then it's like you have an army of cells. They're ready to go to battle, right? Not in a good sense. So that would be the way I would interpret, but don't take my word for it, because I would have to really read to see if someone that went through yo-yo dieting would still have higher risk than someone that never had to lose weight. It's not 100% this my answer.
I'd love for you to look into the research
I will.
and talk to us about that sometime, because I get asked that question a lot. When your sister went from eating at restaurants 3 times a day and eating chocolate to the whole food plant-based low fat diet, did she adapt to it right away, or did it take her a while to learn to like the food? Because so many people say, well, no fat, no flavor. It takes them a while to get used to a lower fat diet.
Yes. Well, let me see. First of all, she didn't change overnight. She tried many times, you know. Sometimes there are people that say, I'm going to do it, and they do it, they never go back. In my sister case, it took her a while. So if she was with me, she would do it and she would love it and she would feel great. Sometimes she would still have like a piece of chocolate. She would still have that desire to have the chocolate. Then she would go back to Brazil. She would do well for 1-2 months. And then one day she'd say, I'm going to have pizza today. She was also vegetarian, always vegetarian, for the longest time. So she wouldn't go for the meat, but she would go back to the cheese. So the cheese and the chocolate would come back. And then she would get together with me again. She would go whole food plant-based for another 3 to 6 months. Then she wouldn't be with me. 2-3 months she would maintain. She would go back. Always the same foods. The pizza with the cheese and the chocolate. Until one day she decided, and then she didn't go back anymore. But she didn't have many problems adapting to. The problem was never the fat or absence of fat. The problem was really just her knowing to react to her emotions in a way that didn't depend on foods. So basically is that, you know, it comes a day when you finally learn, however I feel doesn't require food to make me feel better. When she hit that spot, then those foods never came back again.
That's profound. How did she reach that place? Because so many people watching the summit are emotional eaters and eat because of stress or trauma, or how did she reach that spot?
Yeah, well, one thing I know for sure. So any decision we make in our lives, right, is always about gaining pleasure or avoiding pain. And if we use food as a vehicle to gain pleasure or avoid pain, so we are using the wrong vehicle, right? So for us to be able to change a habit, the pain, because usually, why is it that we cannot change a habit? Because the amount of pleasure we feel is bigger than the pain. And we need to change the math. So the amount of pain to keeping the habit needs to be really higher than the amount of pleasure you get from keeping it. And she found that threshold for her. And it came from the most unexpected place. She has had anxiety in the past, and she even had maybe 2 times in her life where she had panic attacks. And I know you understand how it goes. It's something that I haven't experienced, but I know some people maybe they're listening to us have experienced. And when I was doing some genotyping in her, I know that we found out that both the two of us are slow metabolizers of caffeine, right? So which means that whenever we eat or drink anything that has caffeine, caffeine tends to stay in a system. And then one day, and even though I've never suffered from anxiety or panic attacks, I remember one day I tried to eat a macaroon from a raw food restaurant. And I don't know if it's because it was raw, the amount of caffeine in the macaroon, I couldn't sleep, AJ. My heart was racing to a point that I say, why is it racing? I don't have a test tomorrow. I don't have anything going on. There's no reason. And then I had the aha. I said, it can only be the caffeine in the chocolate. So at the same day, my sister called me and she said, I think I'm in the verge of having a panic attack. I feel awful. Then I asked her, and she was on a diet, so she was not supposed to eat chocolate, right? So I told her, I bet you ate chocolate today, and I bet it wasn't a small amount. And then the phone went completely silent. And then she said, yes, I ate a whole bar. And then I told her, that's your answer. The chocolate, the caffeine is really making you feel bad. And that was it. So she reached that threshold where the pain of keeping a habit it's way bigger than any pleasure she could ever feel. And then she gave up to a point that now if you offer her anything with chocolate, she can have a bite, but she won't have a second bite because she's so afraid, because she dislikes the feeling of having her heart race more than any pleasure she would ever feel by eating that food. So I think it's more like it. So you beat your emotional eating when you reach the threshold. And there are ways for you to get there faster. In her way, it's just it happened like that. And that was it. She was done.
That's great. Do you think that people vary genetically is in terms of how much fat they can eat and be fat? Because I see some of the wonderful plant-based doctors who have never been overweight and that exercise, they can eat like 3 or 4 ounces of nuts a day. And other people like myself and the people I work with, we can't seem to eat any and lose weight or maintain it. Is there a genetic variation in that?
Yes, there is a genetic variation, but like I said before, my sister and I have the exact same genes, and then she had more trouble than me. There is a genetic variation. And like I said before, men and women, two different beasts. So we can never compare ourselves to men. Men on average can eat 51% more calories than we can, more energy. And they don't have any problem being overweight. And in general, they have a third more lean body mass than we do. So we can never compare ourselves to men. So we can only compare ourselves among other women, right? And there is some variation. That's what we say. If we keep your fat intake below 20%, it's going to be almost impossible for us to gain weight. The thing is, if we bring nuts to our diet and if we bring oils to our diet, we are never going to be below 20%. As simple as that. And if we're trying to really lose weight and reverse a medical condition, then ideally we go below 10%. So there's no weight gain below 10 or below 20%. The thing is, how much are you willing to bring back, right? So if you're bringing the nuts back, if you can eat 10 almonds a day or 10 cashews a day, and that doesn't interfere with your weight loss or your maintenance of weight, then you keep it. The thing is, good luck eating 10 almonds a day, right? Or 10 cashews a day, because the likelihood of you being successful doing that long term is very low. So to me, it's like there is a genetic variation, but at the same time, no matter what genes you were born with, as long as your diet it's less than 10, 20% fat, you were kind of protected because it's not a high fat diet. You were in a low fat diet.
Right. I don't know if you'll be able to answer this question, but you're the only one I think that might know the answer based on at least genetics. I've heard like where they've done fecal transplants for people that have certain conditions, and that if the donor was obese, then sometimes the person that got the transplant that wasn't all of a sudden started gaining weight. How is that possible?
Oh, it's very possible. It's like, I love that question because studies have shown already that depending on whether or not you're lean or you're obese, that your gut microbiota is going to be different. And then the question is like the chicken and the egg. I don't like to say this because it's animal products, but it is. What came first, the chicken or the egg? So were you lean or obese because you had different gut microbiota, right? Or is the fact of what you are eating that is changing your microbiota, and the change in the microbiota is making you lean or obese? It doesn't matter right now what it is, what came first, but it is the microbiota of a lean person and an obese person. They are very different. And again, the same way they've done studies on overweight and obesity to show the role that genetics play in overweight and obesity, they did the same with gut microbiota. So they did studies with identical twins and fraternal twins, and they saw exactly that. So obese people and lean people will have different classes of gut bacteria, gut microbiota. So basically, people that are obese will have more what we call firmicutes, and lean people are going to have more Bacteroidetes. So firmicute bacteria, they are more efficient in harvesting energy. Okay, so if you have more firmicutes, what's going to happen is you're going to break down more of your food, and also obese people are gonna absorb more calories than lean people. On average, a lean person and an obese person, if they eat the same amount of food, the lean person is going to absorb 27% less calories than someone that is obese. And it's just by the change in the microbiota. And they did an experiment where they would transplant the obese microbiota to mice that have never had any bacteria in them, right? Any microbes, and they would become obese eating the exact same food. So it is very different. And what is it that changes the gut microbiota? We talked many times before today. The higher the amount of fat, and specifically the higher the amount of saturated fat, the more firmicutes, the more obese type of gut microbiota we are going to have. So it's another reason why. So if we think about it, so high fat diet or high saturated fat is doing what? Is changing how FTO gene is being expressed, is changing how MC4R gene is being expressed, is changing how a microbiota is behaving, is changing all of it's so many ways that high saturated fat diet is changing the way our genes are responding. And that's one of the reasons why we have overweight and obesity related specifically to fat, and to a lesser degree or in a different way also related to the amount of, like I said, branched chain amino acids that we have in our diets.
This is something I know I'm going to have to listen to more than once. I wish you would write a book about this so that I could really, really understand this, because it's really important as well as fascinating. I think the secret to permanent weight loss, from what I'm understanding, is to just come live with you, because that's what seemed to work for your sister. So
it always works. And I had a lot of people say, can I come live a week with you?
Oh my God, that'd be so great. So Dr. Oliveira, what would you say to somebody who's given up hope that they could ever lose weight?
Well, first of all, there's no such thing as giving up, right? So it's if you have never succeeded or you have not succeeded yet, the reason is not because you're a failure. The reason is not because you have not tried, because that's one of the things that I know a lot. I know when you see someone that is overweight or obese, there is that the person doesn't feel good because they know they are being judged, right? And being an identical twin, twins have this shared feelings that is hard to explain. So even though I have never been overweight, I felt some of the shame that is associated with it. I felt some of the judgment that my sister had to receive. Can you imagine if you are overweight and someone looks at you, AJ or somebody else, they're just looking at you. When you have an identical twin, you're always being compared. Why is it that you're not doing the same thing that the other one is doing? So there's always this comparison that makes it even harder. So I can only imagine how hard it was for her, because the comparison is always there, right? So just two people will say, oh, you're twins. But she's heavier than you. Can you imagine? It's just very, very hard. So in a sense, that affected me in a different way than if I was carrying the weight myself. But I know for a fact that anybody that has ever been overweight or obese tried everything they could, and they work hard at it. It's if you have not succeeded up until now, it's only because you didn't know better. But now you do. So it's just a matter of digging in, and I'm pretty sure now you will succeed.
That's beautiful. Are there any genetic tests that you would recommend the average person get?
I should be able to answer these questions, because I get that a lot. There are many genetic tests out there, including 23andMe, where you have a whole genotyping done for you. The problem is that they're starting to be regulated by the FDA, and they cannot give a lot of information out for you. So basically, you can get your genetic test done, but unless you know how to analyze it yourself, you may not be able to get a lot of information from it. Like I'm talking about FTO, maybe FTO they talk about. I can't remember. They used to give this result in 23andMe, but I'm not sure they do that now. So I would have to look into it for you. You should have asked me that before, so I would
That's
have
okay. I will definitely want to talk to you again.
The thing is, there are tests out there. You just need to know if what they're going to give back to you is going to be informative. And the other thing is, I cannot remember, there's a genetic test that I've taken in the past, and I believe they tell you about FTO. I'm not positive, but they also tell you what is the best diet for you. And they may be telling you it's a Mediterranean diet, or it's high fat diet, or high carb diet. So, and as you can tell, I'm not into different diets, right? So I know which is the diet that is the healthiest and will help you keep your weight, lose weight, and bring you health long run, in the long term. So to me, that's the diet everybody, or not even diet, the lifestyle everybody should be jumping in to follow. It's the one that's going to help you lose weight and be healthy and have longevity and reach, right? Longevity more so than any other diet that may bring you weight loss in the short term, but will not help you be healthier and will not increase the years you have on this beautiful planet.
Right. So, Dr. Oliveira, one more question. What is the real truth about weight loss?
Real truth about weight loss. Well, to me, is no matter what genes you were born with, you're in charge. And it's mostly about the foods that you choose to go through these lips every single day. They're going to get you there.
That's wonderful. Thank you so much.
You're welcome. Bye.